I'm Ramesh Raskar, and it is my honor to be a co-chair for the healthcare track with Dr. Reena Bhatia. And I must say that I'm encouraged by the attention healthcare is getting at TiEcon, because those of us who have been in the space of healthcare have often been underwhelmed, if not frustrated, at the lag between our sector and other sectors in adopting technology. But today, our speakers, which is a great list of speakers that you will see, will probably share with you that that gap is becoming less in adoption of AI. As Reena and I started conceptualizing the track, we wanted to make sure that we covered the whole gambit from development of drugs and solutions all the way to patient care. And Reena, being a doctor, took the lead in the healthcare delivery part of this. So we'll have a life sciences part and a healthcare delivery part. And Reena will talk more about the healthcare delivery and also introduce our first speaker. Reena?
Thanks so much. Thanks, Ramesh. Distinct pleasure to welcome you all to this track. We've put our hearts in it and developing this, and we got some amazing speakers. Bottom line, healthcare in this country and around the world is broken. We all know that. $4.3 trillion spent last year in the US towards healthcare, and a lot of that came from the taxpayer. We've now reached, with generative AI, a launching pad to change this fragmented healthcare. And I am going to invite our first keynote speaker, Professor Ramesh Raskar from MIT, who's come down just for this. He'll be talking about decentralized AI. Ramesh has been leading the digital health platform at Meta. He's been at X. He's been with Apple, done a great amount of stuff in vision and camera technologies. And so, without further ado, Ramesh, if you would join us and share your insights. Thank you so much.
Hello, everyone. So let's talk about the God AI. This is the ultimate problem we need to solve. I was at Burning Man with Dr. Daniel Kraft, who's also here, a few years ago, and I saw this booth that says, a telephone booth that says, "Talk to God." And how many of you would actually pick up the phone and say, "Let's talk to God," right? And you would ask a lot of questions. If you have been there that year and picked up the phone and talked to God, the voice on the other side had a very thick Indian accent. And that was me. And for days, people shared, their deep, very painful secrets with me, things that are bothering them and so on. And I was very surprised with that. It completely transformed me as an individual. And the question I asked was, what makes them share all their secrets with me? And the obvious answer is that they think a God-like entity is an impartial, honest broker who can not only listen and provide some guidance, but also has the power to go and talk to everybody else involved in that situation and see if it can be resolved. And so when I went back to MIT to do my research, I said, this is the problem we need to solve. Wouldn't it be great for every problem we face, there is an honest, impartial broker? And of course, without getting religious about it, that impartial broker is going to be AI. And one would argue that there are already different gods in our life. Like, who's the god of traffic? That's Google Maps. Because, as we are, even if you have the best car, even if you think you're the best driver, when you want to get from point A to point B, even if you know the route, you fire up Google Maps or Waze, and you willingly give away your GPS location to the traffic god, which is Google. They analyze all that information and give us back an impartial, honest answer by being a broker amongst all the cars who are providing GPS coordinate, right? And so what we need is ways for life, right? And there are many challenges to make this happen. So before we get into that, let's think about how the AI revolution is playing out And is it on a path to become, a God AI? And if you think about the AI stack, there is the core AI, and then there's applied AI. And I know you're getting a lot of jealousy of the people who own NVIDIA stock, and maybe OpenAI, Anthropic stock, but that's just the tip of the iceberg. Because if you remember the Cray supercomputers and IBM mainframes, they didn't have their glory for too long because they had a very centralized approach. What came after that, the applied AI, and analogy with the internet would be, the eBays and AOLs and Google and Facebooks of the world are the ones who actually captured most of the value. And the same thing is going to happen in AI, in the applied AI world. And this chart is actually created by McKinsey. So the horizontal axis is amount of value. And there's one thing we should all remember. We should trust these analysts, right? Because they're telling us this is how it's going to evolve. And so, if you want to really create very strong moat AI companies, we need to think differently. There's no free lunch. On the bottom left, you have a lot of screen AI companies, which is chatbots, summarization tools, creativity tools, and so on, which are called screen AI. And these are easily created companies, but also very easily appended. But on the top right is what I call dimensional AI companies, companies that will be in healthcare and transportation and agriculture and smart cities and so on. They work in the three-dimensional world and require dimensional teams to execute. And so one of the venture studios I run is called C10 Labs, and this is what we do. We create these strong moat companies by partnering with very early stage founders and corporations. So if you're thinking about new types of dimensional AI companies, please apply to our cohort. Just go to c10labs.com. The earlier stage you are, the better for us to help you to spot new problems, probe unique solutions, and launch pre-seed ventures. All right. So that's how we can think about AI when it comes to venture creation. But what about the sector itself? I mean, ChatGPT, is it going to take us all the way? And ChatGPT is really about public information. But what really matters, especially in sectors like healthcare and finance and so on, is that we need access to the enterprise data, highly siloed data that may be difficult to access because of regulation or trade secrets, and also simulations, real-world pricing information and so on. And that's the deep web, not the dark web, but the deep web. And that's where most of the value is going to come from. And the world GDP is $100 trillion. And we all know that nearly all of that $100 trillion GDP is going to be impacted by AI, maybe in the next 5 to 7 years. It's going to be a massive transformation. And most of that GDP is below this line, not above this line. So that's the promise of decentralized AI. And if there's one chart I want you to walk away from this presentation, is making a distinction between AI behaving like an assistant, which is not on this slide, versus AI behaving like an engineer, and AI behaving like a scientist. And then for a lot of these things, we have to think about, is all the operations centralized or decentralized, right? Because if you think about companies like OpenAI and Anthropic and platforms like Gemini, they're not only centralizing the data, they're centralizing compute, centralizing talent, and more importantly, centralizing the governance. And this is completely unsustainable. This is like, again, the Cray supercomputers and the IBM mainframes of the 80s and 90s. So we're going to go through this transformation toward decentralization very quickly. The AI PC is coming this summer. And just as mainframes were completely destroyed as a market when Steve Jobs and Bill Gates started the revolution in the 80s with PCs, we're going to see a similar revolution with AI PCs coming up, in the next few months. So let's walk through some of these examples very quickly. So there are areas where we can do simulations very accurately, and they match reality. A good example is autonomous vehicle. So a lot of the work we do and others do is just use simulation, not worry about data, right? So that's great. But let's think of a more complex example, like shopping, co-pilots. So, who here gets excited about kind of designing a themed birthday party for your kids or your loved ones? And who gets really stressed out? All right. So I do get stressed out. So imagine if I can just, pick up my phone and say, in my daughter's birthday is coming up in a month, I just say, hey, shopping AI, my daughter's birthday is coming up, send me the best solutions and the products. And what the shopping AI copilot should do behind the scenes is extract all my photos, see what my daughter likes. Does she like more Star Trek or more Barbie? Also extract the photo rolls of all my friends' phones and see if my daughter is in those pictures, what kind of previous birthday parties she has enjoyed. And then go and talk to all its vendors, and say, hey, do you have inventory for the Barbie-themed birthday party, or her inventory for a Star Wars birthday party? And then the shopping AI already has a 3D model of my house and my backyard. And through Gen AI, I can just move my phone and see a video that's generated of my daughter playing and enjoying her birthday party with her friends, right? And it'll give me 3 options, $100, $500, $2,000, and I can just pick one, and all the materials gets delivered to me in a week, right? In a matter of seconds. So to get there, right, I think hopefully that will reduce your stress of planning birthday parties. The mindset shift here is that instead of walking the aisles of Target or Walmart or pick your favorite store and trying to find a product, and this company is selling us product, they need to buy our need to just celebrate a birthday. And the AI behind the scene, the dimensional AI, the decentralized AI behind the scenes has to figure out all this works all the way from the supply chain, the data coming from a phone, training machine learning models, incentivizing me and my friends to participate in sharing these photo rolls, also vendors to participate in sharing their inventory, which is their trade secret, and creating this amazing UX and kind of drive this experience, right? And this is the future of decentralized AI. So let's talk about scenarios where the simulation and reality are going to be very far away. So healthcare is a great example where there's simply no simulation of if I give you a particular drug, how it's going to make you better, right? Or molecular interactions or change in consumer behavior. So in many areas, the simulation and reality is too far away. And so we have to think about new kinds of models, not large language models or large vision models, but large population models. And that takes us into the world of agents. And if you think about these two axes of intelligence versus networked intelligence, we're kind of making progress on the horizontal axis. Right now, we have kind of a clumsy AI. We have to go and search for something and keep that in mind and go on something else. And very soon, we're going to shift into the world of personal agents, where we don't have to proactively go and search for information and answers, but the agents will do that on our behalf, in a semi-passive way, might even take actions on our behalf. So that's an exciting world of personal agents. There's a lot of excitement there. And you can imagine, we're going to have 8 billion digital twins for every one of us, and each of us will have dozens of agents. So this 30, 40, 50 billion AI agents are going to be talking to each other. And the question is, what is the path we're going to take to go to the top right, where you have this tens of billions of AI agents talking to each other? And this is where the decentralization comes in, because if you're running a healthcare system in Indonesia, it's unlikely that your insurance company, your hospitals, your national healthcare system is going to ship all the data to Sam, and Sam is going to train this amazing model, and people in Indonesia are going to just use those APIs. That's unlikely. And what's going to happen is each of those entities are going to run their own small models. They'll talk to each other, right? And Marvin Minsky, who was also at the MIT Media Lab, wrote this brilliant book, The Society of the Mind. And the key concept there is, our brain is not this one supreme entity, but there are many small aspects of our brain, our memory, our reasoning, our planning, and they all talk to each other. And same thing with all of us. Even the most influential person in the world doesn't have a big brain, but they all rely on people around them. So the society has already figured out how to be highly decentralized and have obviously 8 billion human minds, and we can work together to create a globally sustainable, globally prosperous society. The question is, are we going to go down this horizontal route of trying to create extremely smart agents that just kind of stay amongst each other? Or are we going to start a parallel revolution where there are very small agents, very simple agents, they don't do much, but they're highly networked, right? So let me show you a path in that direction that my group and others are doing in healthcare. So, a natural question during COVID was, should, a government like US or UK spend billions of dollars in distributing imprecise, antigen tests that give very quick results in 15 minutes, or use very slow and expensive PCR tests that give results after 2 days. And what we did, worked with the UK government, it showed that we can populate 60, 80 million agents, healthcare workers, teachers, children, diabetics, smokers, that mimic the population of the UK, and run these models very quickly, not for prediction, but to see what knobs should be turned, right? And this is a very amazing new field of agent-based models for AI. And they allow you to calibrate models, simulate population behavior, inform policy, and so on. And clearly, every agent here is very simple. A teacher agent just simulates and talks to its students, and they take the train in the morning, file their taxes. They're very simple agents. But from that, we can simulate behavior of all populations. So it's a crystal ball into policy intervention. But this particular idea of agents, personal agents, that become better and better over time is very critical. So let's take another application from healthcare. Imagine, there is Sarah in rural Texas. She's having chest pain. She recently had COVID. Her family has history of cancer, and she's just not getting good suggestions, good advice from her doctors in rural Texas. So imagine, this doctor in rural Texas can just go on the internet and say, for $10, can I get a really good answer for my patient? I'm willing to upload, the radiology, pathology, and health status for Sarah. Just imagine that world. And if we have this God's eye view, the God AI, then we can actually do this, right? We can bring tens of millions of petabytes of data from all over the world. Anybody who has chest pain, even if anybody who had long COVID, bring that in one location in rural Texas, train the best machine learning model, which could cost millions of dollars. Then take the $10, which is nothing, and give the money to the people whose data was used, but not to others, and finally create, a treatment plan that looks like, buying tickets on Expedia. Treatment plans that are more aggressive, treatment plans that expect her to go to Houston, and so on. So we can all kind of agree that if we have God's eye view, we can solve problems in healthcare nearly overnight. Right? Of course, the reality is that we cannot bring all the data in one place. We cannot centralize it because of HIPAA, because of trade secrets, even national security issues. We cannot train the best machine learning models. What does even best mean? Because the way you would treat somebody in Texas is different than the way you would treat somebody in Indonesia. $10 is not much, and how do you figure out who should be paid back and who's not? And then finally, what does it mean to create this highly explainable, highly interpretable treatment plan? So there are a lot of challenges in pushing decentralized AI into healthcare. So that's where the godlike AI comes in. And we want to create this global orchestration of decentralized AI, GOD for AI. And the good news is that components of Web3, who's still excited about Web3, by the way, and crypto? Some people are, good. Whatever those guys did, it was a little bit scammy, but the good thing from a computer science point of view is that many components of decentralizations have already been built, right? And we can take those components and building something amazing for the AI. So we have to work on 4 main problems for pushing decentralized AI, which is new privacy tech, new verifiable AI, forms of data markets, and a completely new form of UX. So let's walk through that very briefly. So the first one is privacy tech. So the god of traffic might be Google because we willingly give away our GPS location, so we have no privacy. But Google gives us amazing utility by giving us traffic information and turn-by-turn navigation. Imagine if we could do the same thing in healthcare, where we can centralize all the data. It's not possible because of privacy. So what we really need is a mechanism to go on the top right, where we get utility and privacy at the same time. And this cannot be done with anonymity, because that's not privacy at all. There is always a breach. Data obfuscation with techniques like differential privacy, or full-fledged encryption. But those methods, unfortunately, are not compatible with most general-purpose AI. So 2 techniques have emerged over the last 5 years. One is called federated learning from Google, and another one is called split learning from our group at MIT. And this privacy-preserving AI is kind of the first strike at potential decentralization of AI. And the key idea behind privacy-preserving machine learning, privacy-preserving AI, is don't share raw data, but share the wisdom coming from that data. The next problem is, how do you actually figure out that the AI that's built and serving you, these billions of agents, are actually real? How do you verify them? And so again, technologies from the blockchain world, like ledger tech, can be upgraded to do this. Third is, what about data markets? Of course, that one rural doctor's $10 means nothing, but at any moment, there'll be thousands, maybe millions of such doctors, spending $10 each to get their own feedback. So there could be tens of millions of dollars of activity going on at any given hour. And the question is, how are you going to combine all of that? Because you don't need to train one specific model for chest pain. There'll be foundational models that are being trained, and only the heads, the task-specific aspects of that model need to be trained. So there's a lot of amazing work that's going on in how do you merge different models and don't have to train again and again when they have done the foundational work. But the question is, how are we going to extract the data? How are we going to pay for this data? And you're probably hearing about all these lawsuits from New York Times and Reddit, across LLM companies. And I believe Reddit just got $60 million for their data. But how do you evaluate this? Are we always going to do this through lawyers and litigators? Or is there going to be online marketplace where in a fraction of a second, you can figure out what the value of each data is, right? So that's another direction that our group and others are working on. And finally, we need new types of UX, new types of exchanges. Just like in the Web3 world, just managing your keys was painful. That's why exchanges came around. But for discovery, visualization, and decision support, we need a new form of crowd UX as well. So I think this revolution in decentralized AI is going to create so many new opportunities, new ventures, new research directions, and also going to upend many of the existing business models. Of course, the concern is there are risks when things are highly decentralized. Algorithmic social orchestration has many failures. Anybody was an investor in FTX or Luna or Terra? And then, of course, bad actors can, introduce adversarial data. Once they know that they might get paid, several dollars for contributing to this decentralization, they might just start inserting faulty data or erroneous data into it. So verifiability also becomes challenging. So nevertheless, I think if you think about how AI is going to behave like an engineer and a scientist, we quickly realize that centralization is not an answer. It has to move towards decentralization. And it's not just applicable to sensitive sectors like health or finance, but many other areas where different incentivization structures are critical are important. Now, next time you go to Burning Man, hopefully they don't say talk to God, but they should say talk to gods, plural, because where I come from India, we have already figured out that gods should be decentralized. We have 33 crore gods, 330 million gods, and we have figured out how to decentralize them, and we have a god for every task, and there's only a society of gods, not just society of the minds. So I think, there was a lot of wisdom in creating that decentralization, and hopefully we can use the same wisdom for AI. Thank you.